Hello, my name is Mustafa Perengürbüz and this is Lab 5 for Physics 2211 and I chose the following Slinky. So here's a quick table of contents. I'll first go over the introduction, talk about the system surroundings, initial conditions, models, and assumptions. I'll go over the tracker video, data, and its results, the glow script video and its data and its result, and then talk about what's different between those, and then answer the questions what if or what does it mean. So the purpose of our lab, in this case, is to compare the two different motions of the top and the bottom of a slinky when drops. So what happens to the top, what happens to the bottom part of the slinky. And the main physics principles we're going to use is the Newton's second law, which is the acceleration of an object is directly proportional to the force acted upon it and inversely proportional to its mass, commonly known as F equals ma. The gravitational force, and that's just the force of gravity acting on an object, which is F equals mg. A quick preview of our main result is that the top of the slinky kept moving down immediately when dropped, but the bottom of the slinky remained relatively non-moving until the top came to where the bottom of the slinky was. So the system and surroundings, the system of this experiment is the slinky, and the surroundings is the gravity, the hand, and the hand of whoever released the slinky. The initial conditions in my case were 1.75 meters, which was the initial height of the slinky at the top, and initial height of the slinky at the bottom was zero point 0.6 meters. Some assumptions I made in this experiment was that the Slinky was falling in a straight line without outside forces acting upon it, and the mass of the Slinky didn't change, meaning it was constant. And the model I used for this was a position versus time model in meters versus seconds, and a velocity versus time model, which was in meters per second versus seconds. So this is my tracker data. As you can see, I found the height of Veritasium, 1.75 meters, plotted that as my reference point, and then plotted both mass B as the top and the mass A as the bottom, and I did my track data that way. So here's the results. As you can see, mass A, which is the bottom of the slinky, remains much, much more constant, which is like non-moving, until the collision with mass B, which is the top of the slinky, happens, and that happens at zero point 0.4 seconds. So after that, you see there's a downward sloping trend, just like with mass B. Here's my glow script model. I just added the top and the bottom of the trails, made them blue and red differently, and then used different types of curves, Newton's second law principles, to model these, similar to how we used in the oscillations lab and in most other labs, basically, is when we did Newton's second principle. And here's the results. The red line that you see in these graphs is the bottom, and the blue line that you see is the top of the slinky. And in these ones, you can also kind of see the red line, like for example at the top, is much more constant until the collision happens, which is when it starts to go down, etc. So here's a comparison. Again, until they collide, the red mass doesn't start to decrease. And that's also seen in velocity. Velocity is 0 until the collision happens at zero point 0.4 meters. Some possible errors in this is that we didn't take into account drag force, so that might have changed things slightly. The air resistance slightly might have changed it, so we didn't account for that. And the points on tracker could have been slightly misplotted, altering the data and altering our results. So what if or what does it mean? It would compress and expand due to the kinetic energy in the slinky, and the tension of the slinky would be stopping the bottom of the slinky from being pulled down because the tension is pulling upwards on the slinky. But when the top of the slinky comes all the way down to where the bottom of the slinky is, then in that scenario, there's no tension, meaning they get affected the same rate, same amount. So then it gets pulled downwards. So yeah, thank you all for watching.